Hi, this is Jeff Spence, your Math 120 instructor for the Community College Denver, and this is our video lecture over section 7E. So, on this section, we're actually going to be figuring out the number of ways that events can happen, various events. So, we're going to have some distinctions to make, and the first distinction we're going to look at is when we look at arrangements with repetition. So, if we make a certain number of selections from a group of n choices, a total of n times n times n times n, n to the rth power different arrangements are possible. So an example would be how many 7-number license plates are possible. So if we had 7 numbers, had to fill in 7 slots, and we had numbers to choose from, like a California license plate, we have 10 choices for the first, 10 choices for the second, 10 choices for the third, and so on. And the other thing is we're allowed to repeat the values. In a license plate, it's okay if you have a 6 that you can have a 6 later on in the license plate. So there's 10 choices for each one. So there is repetition. Repetition is allowed on here, even though this example doesn't show it. So if we want to know how many 7-number license plates are possible, we take 10 times itself 7 times. We get 10 to the 7th. 10 million different possible license plate combos. So, permutations. We're dealing with permutations whenever all selections come from a single group of items. No item may be selected more than once, so this is, we cannot repeat or select the same thing twice, which was not true in the previous example. And the order of the arrangement matters. Okay, so A, B, C, D is different from D, C, B, A. Things where order matters is like, when we select president, vice president, and treasurer, things that involve rank, order from left to right, passwords, order matters. So let's look at an example here. So the total number of permutations is n exponential. Okay, so the first example is a middle school principal needs to schedule 6 different classes: algebra, English, history, Spanish, science, and gym, in 6 different time periods. How many different class schedules are possible? Well, with a schedule, order matters, okay? And we're selecting from a group of 6 classes to fill 6 slots. So the idea is that we have 6 options for the first period, and then once we pick one, now we have 5 options for the second period, 4 options for the third, 3 for the fourth, and etc., until we get to 720. So the principal can schedule the 6 classes in 720 different ways. However, generally we'll want to use the permutation formula and not just multiply out like this. So if we make our selections from a group of n choices, the number of permutations, arrangements in which order matters is this formula here, and I'll show you how to enter this formula into your calculator. So let's get to an example. On a team of 10 swimmers, how many possible 4-person relay teams are there? So the idea is when we're selecting people, there's no repetition. We're selecting from the same group of 10 swimmers, and order does matter when we select a relay team, because usually you want your fastest at the end. So order definitely matters here, and we're selecting without repetition. We're not going to select the same person to do all legs of the relay. So this means that our n here in the formula is 10. That's the number that we're selecting from. That's how many choices we have. And our r is 4, because that's how many we're selecting. So to show you this on the calculator, we just have to do 10 permute 4. So let me grab this. Okay, so the way to do this in the calculator is you start with the number 10. Oops, my calculator froze, so let me clear it out here and open it again. Alright, so we type the number 10, then we press the math key, and we go over to probability, and we pick the permutation formula here, NPR. Pick that, and then we tell it 4, the number 4, because that's the number that we're selecting, a 4-person relay team. And this will tell us 5,040 ways that you could select this team here. So we have 10 choices for the first, 9 choices for the second, 8 choices for the third, and 7 choices for the second. There will be 5,040 relay options. And I did that with the calculator. Let me just go over it again. I'm selecting from 10 things. Press math, go over to probability, pick the permutation formula. I'm selecting 4 things. Order matters. If an international track event has 8 athletes participating and there are 3 medals, gold, silver, and bronze, to be awarded, how many different orderings of the top 3 athletes are possible? Well, with this, order matters because for gold, silver, and bronze mean different things. So order matters. We're selecting from 8 athletes, and we're not going to have the same. Not going to have one athlete get gold, silver, and bronze. So there's no repetition here. So this means we're going to do our permutation formula here. With 8, we're choosing from 8 things. We're choosing 3 from those 8 things. I'll show you math in the calculator. We would start with the number 8. Go to math, over to permute. Pick that function. We want 3 and 336 ways. And this is showing the math of the formula. There are 336 different orderings of the top 3 athletes. Okay, a little league manager has 15 children on her team. How many ways can she form a 9-player batting order? So in baseball, batting order definitely matters. We're not going to select the same person for each spot, so there's no repetition, and we're selecting from the same group of 15 people. So this means we want to do 15 permute 9. We're selecting 9 out of 15 where order matters. So start with 15, math, over to probability, down to permute, and we're selecting 9-person lineup. There will be, let's see here, 1,816,214,400 different lineups. That's a lot. 1,816,214,400 different lineups. Whew, nearly 2 billion battering orders. That's crazy. All right, combinations now. They occur when we're selecting from a single group, which is just like the last thing. No item can be selected more than once, so that's the same as the last thing. But the main difference is that the order does not matter. Okay, so there are various examples where order does not matter. So we would say ABCD is considered the same as DCBA. This obviously wouldn't be a password where order matters, but maybe we're just selecting 4 people for a committee or something like that. And here's our formula, and we're going to use the combination formula. So usually when we select a committee, a group of people to represent something, the order of who we select does not matter. It's just that we have a group of people and there is no rank or class within the committee. So if we want to select a committee of 3 people out of 8, and there's not any distinction between committee members, order doesn't matter, how many possible committee members would there be? So we're going to do the 8 combination 3 formula. So go into our calculator here. We type the number 8, math, over to combination. That's just one down from the permutation formula that we've been using. And now we want to select 3 committee members. And there are 56 different possible committees that you could create. There's our answer. And so that's it for this lecture. The big thing is that you need to remember, if there's any repetition, then you're going to use the multiplication principle here. If there is no repetition, then you have to just decide if order matters or not, and that's the hard part of this section. And then if order does matter, you'll use the permutation formula like I was using. If order does not matter, then you're going to use the combination formula. Good luck, and we'll see you next time.